Okay, welcome, and today we're going to work this problem. This is homework 2 from spring 2021. All right, so for this one, we're going to solve this problem in two ways. We're going to solve it using the triangle method, and we're going to solve it using components. So basically what we're going to do is we're going to add these two vectors, A and B, and we're going to add them twice, and then the second time we're going to make sure we're going to convert the answer into polar coordinates so that we can make sure that this all makes sense. Okay, so a big important thing about this is I want you to learn the format here. So I'm just going to go ahead and do this all with the correct format. Okay, so I'm going to go over here. So part of the correct format is about having graph paper. Well, here's the name. This is my name. I don't have a student number. But anyway, so let's, so here's a given. Okay. You can write this out in two ways. You could either write something like A, and then how you would define that. So you could say the magnitude of A is, or you know what, actually, I think the way that I would typically do this is I would write A, sorry, my dog popped up and started panting, equals 217 pounds at an angle of, well, looks like it's 80 degrees from the horizontal. Okay, so you could do that. And there's obviously a few different ways that you could write that. You could write 217 pounds at an angle that looks like this, 10 degrees. Okay, same thing. Just depends on how you want to do it. And then you could do B. Now, in this case, I usually, that's probably not how I would do this, typically because what is given is a drawing. And the drawing to me makes the most sense. So usually what I would do in this case is I'm going to use the drawing because I'm going to work on my drawing as well. Okay, so this is the y-axis and this is the x-axis. Okay, and I've got two vectors that we need to draw. Okay, and you're like, well, do I have to draw it? It's already right there. Well, yes, you have to draw it. Okay, here's B and here's A. Okay. And then this thing right here, that's 10 degrees. This angle right here, that's 26 degrees. And this is 217 pounds. And this is 408 pounds. Okay, so those are the givens. Okay, so unfortunately, we're using the English system of units. All right, so once we've got the given down, then we need to know the required, and then we can actually get to work. Okay, so the required is A is A plus B equals what? Using triangle method. And then B, A plus B equals what? Using components. Now, my students don't like to write all this out, and I understand because it's kind of annoying. But if you time this, you realize it just took me like an extra 2 minutes to do this. So I'm not going to really be all that forgiving of you if you can't do this. Okay, and then the last thing is kind of like, okay, confirm the results from A equals B. Okay, so that's the last thing that we need to do. Okay, I don't really know how to write that out in words. Okay, but something like that. We want to make sure that the results from A and the results from B equal to each other. Okay, so now that we've done all that, by the way, on a test, you don't need to do all this. Okay, don't write the given and the required on a test. There's just not enough time. Okay, so here we're going to do a solution. Well, it looks like I'm using colons here. We'll kind of stay with that theme here. Solution. And we'll do A. Okay, so using the triangle method, what we're going to do is what I do is I start at the origin, or something that could be considered the origin. I'm going to go 217 or whatever that might be in the direction of A. Okay, so this is 217 pounds. Okay, now a key here is that we want to get these angles. Ideally, we would do this with a protractor, but that's really not necessary. So I'm going to zoom in and put my 10 degrees right there. Okay, and then so I'm going to put B tip to tail. So now B we're going to turn and we're going to go this way. Where are we going? 26 degrees and about 4. So we'll go 1, 2, 3, 4. So maybe somewhere out here like this. Trying more or less to be in scale. Okay, and let's remember that that is off of this angle right here. This is the horizontal. Okay, and that's 26 degrees, and this is 408 pounds. Okay, so this is the triangle method, and so here's the resultant right here. And I don't know why I've chosen green in this case, but I have. Okay, so there's the resultant. Okay, so the things we're adding up go tip to tail, and everything else is the resultant, and this is the angle that we're going to want right here. Off of the horizontal. I mean, you could do it off the vertical too, but it's more typical to go off of, that's the angle. So we'll call that theta that we're looking for. Okay, so now we have to do a little bit of, what do you call it, geometry in order to figure this out, because I don't have any of the angles on inside of this triangle. I know the sides. I've actually kind of drawn them in a bad spot, you know, but this 217 refers to that side, and this 408 refers to that side. Okay, let me just go ahead and rewrite those. 408 pounds. And we'll write this 217. Maybe we'll write it right there. Okay, and that's kind of one of the challenges of these things, is figuring out where to write these things. And for some reason, it won't let me erase the 217 itself. There's something special about it. Let's see if we can erase this as well. Okay. So then, and this right here, this right here is A plus B. A plus B. Okay, so all right, so let's go ahead and solve this sucker. Okay, so what we're going to do is, you know, as I zoom in here, so that you know, we've got this thing almost too big, is I want to think about, you know, this right here. So there's so we know that this angle right here, okay, going from basically, let me see if I can draw this in, let's say red. Like that. I know that this part is 26 degrees. I know that this part is a right triangle. So now we've got 26 plus 90. And then I just got to get this last bit right here. And that last bit is equal to this from alternate interior angles, right? Because this is parallel to this. So this little last bit right here, this is 10 degrees. So I've got 10 degrees, I've got 26 degrees, and I've got 90 degrees. So we can add all those up. And I can say that that whole angle, this whole, like, this angle right here is what, 126 degrees. Okay? Okay, and so that's how I get that one interior angle. And I need that angle, right? Because what I can do once I have that angle is that can help me get this green side of this triangle, right? Because what I can do is I can say, so the green side, that's c squared equals, this is the law of cosines, equals a squared plus b squared minus 2ab cosine of the angle between those two. So typically that's called gamma. We didn't really call it anything here, but gamma is the angle between the 217 and the 408. Okay, it's the angle across from C. So this is side C. Then this is gamma over here. Okay, so let's go ahead and solve this. We're just going to go ahead and plug and chug here. Okay, it doesn't matter which one's A and which one's B. However, I'm going to try to keep them, you can keep this color coded. So A squared in this case is 217 pounds. We'll square that, plus B squared, which is 408. Oh, there's a pounds in there, squared, minus 217 pounds times 408 pounds times the cosine of that angle, which we decided was 126 degrees. And I'll just go ahead and put that in red, 126 degrees. Okay, and maybe we'll keep the parentheses in blue. Okay, so if you do the algebra on that, you can get the C, which is the magnitude of this whole thing. So C equals, obviously we're going to have to take the square root of all that. 557.83 pounds. Okay, so we always keep 5 significant digits, and but we report 3, okay, at least in this class. So C, or we could say that A plus B, the magnitude of A plus B, so the magnitude of A plus B. I'm not sure if that's how you would write that, but that's how I would write it. For for reporting purposes, we would say 558 pounds. Okay, so this is the answer you're going to box, but this is the answer you're going to work with. Okay, and so this is the one that you box is the one that you're going to report, and the one that you're going to work with is the one you're going to work with. Okay, so all right, so that's the magnitude, and then we need to get this direction. So we got to get to that angle, and so the way that I would get that angle is, I guess we'll go back to, well, we use black for this, is that I would recognize that this is a right angle right here, okay, of which 10 degrees is taken up here. I don't know what's being taken up right here, but I know that the 10 plus this, which I'll call, I don't know, let's call it beta, 10 plus beta plus theta all add up to 90. So this plus this all add up to 90. Okay, so if I can get beta, I can get theta. Okay, so the way that I'm going to get beta is I'm going to use the law of sines. So the law of sines looks like, well, we're going to, so let's see here. It's going to be C over the sine of gamma equals, let's try B over the sine of beta. Okay. Now notice, I could have kept going. I could say also equals A over the sine of alpha if I wanted to. Okay, but there's no need to do that, right? Because I have enough information with what I've just done. Okay, so what we're going to do here is C. So that's 557.83. Okay, so I'm working with this one. Okay, divided by the sine of gamma, which again, I'll put that in red, 126 degrees, 126 degrees, okay, equals, and then here we've got B, which the side across from beta is right up here, so that's 408 pounds, divided by the sine of beta, okay, which beta is black, so we'll say sine of beta. Okay, so we'll go ahead and solve this. Okay, so beta equals 30. No, come on, you can do it. 36.297. Okay, 279 degrees. Okay, and again, that's the one we're going to work with, but we are going to report 36.3 degrees. Okay, so so your answer, if we're reporting this, is going to be something like A plus B equals, or we could call that C if we wanted to, equals 558 pounds at an angle of, okay, so the angle is rising off of the x-axis by 36.3 degrees. Okay, so we report 3 significant digits. Okay, so this would be your answer for A. Okay, and hopefully we're going to get the same answer for B. I guess we'll find out, right? Now, one thing to be sure of is to make sure that this makes sense. If you look at this triangle, A plus B should be bigger. Like if you look at the magnitude of this, you note that it should be bigger than both this 217 and this 408. And sure enough, we got 558. And then this angle, 36.3. Whoa, did y'all catch that error? You've probably already emailed me, haven't you? Oh, that's not it. Oh no, right? Okay, so this is why we think about these things at the end. If this thing will let me scroll, is that was beta, right? We don't want beta. We want to know theta, right? So let's get some green here. Okay, because remember theta is right here, right? So if this is beta, then we can say that theta plus beta plus that 10 degrees, so these 3 added up equals 90 degrees. Okay, so if I plug in for beta 36, so if I plug in theta plus 36.279 degrees plus 10 degrees equals 90 degrees, then theta equals 43.721. Okay, 721 degrees. Okay, again, no one really wants that many significant digits, but you just save that in case you need to work with that number. So we'll go ahead and put 43.7 degrees. Okay. Again, 43.7 and 36.3, like we wouldn't be able to tell by thinking about it which one of those is correct. But so there it is. That's A, 15 minutes. All right, so that's A. Now let's do B. Okay, so B, we're going to use the component method. Let's see, so we'll go right here, B. Okay, and for B, what's nice is we can kind of, we can do this kind of, oh no, it slipped. Okay, oh man, okay. Well, it's not very good use of a straight edge. All right, let's see. So we've got something going up here like this. I think this was 217 pounds, and this is 10 degrees. And then going off this way at 26 degrees. At 26 degrees, we've got 408 pounds, sorry. Okay, so what we're going to do with these is, well, we're going to break them down, okay? So this one's A. I don't know where to put A. A is over here. This one's B. Okay. So anyway, so what we're going to do is we're going to decompose these. What a lot of people like to do is they always like to take the angle with respect to the horizontal because that makes the trig slightly easier. I like to make it so that I'm always remembering my trig. So what I don't like to mess with this 10-degree angle. If you give me a 10-degree angle, I could convert that to 80 off of the horizontal, but then I'm just creating a possibility for me to make an error. So instead what I'm going to do is I'm going to complete my triangle that way because I already know that angle in the triangle, right? So now I've got this, okay, that's AY, and here's AX. Here's AX right here, like that, okay? And then on this one, I already know that 26, so I'm just going to drop this straight to that axis. There's my triangle, right? So now I've got B in the X right there, and B in the Y right there. Okay? So now I'm going to erase these 217. I'm going to put it where I should have put it in the first place, which is right here, 217 pounds. I'm going to put this 408 pounds right here, okay? Because that's more geometrically kind of what's going on here, right, than putting it at the end there, okay? Anyway, so now we can get to work, okay? So we can start splitting this thing apart. Now, once you get really good at this, the trig becomes really easy, but I'll go ahead and walk through it again here. So here's my right angle for A. Here's my right angle for B. In both cases, I have the hypotenuse. I have the angle across from the hypotenuse. I have the side across from the hypotenuse, right? So if I'm going to do SOH, so is sine of the angle, okay, any angle, okay, equals, well, right, so let's take the case of this 10 degrees. The sine of that angle is the opposite. We'll call this AX. We'll call this A in the Y direction. So in this case, is the opposite AX over the hypotenuse, 217 pounds. Okay? The cosine of that angle, well, let's just go ahead and put in the 10 degrees because that's the angle we're working with. Okay, let's go ahead and put in the 10 degrees here as well. Come on. You can do it. There you go. 10 degrees. Okay, so the cosine of that angle is, let's see, so the adjacent side, so it's the side next to it, that's AY over the hypotenuse, 217 degrees, right? And that both of this comes from SOH, right? So cool. So I could rearrange this. So I'm going to rearrange this one. Okay, these are not equal signs, by the way. So that I could say that AX equals 217 pounds times the sine of 10 degrees, and AY equals 217 pounds times the cosine of 10 degrees. Okay, so I could solve for both of those. Okay, and again, I'm keeping 5 significant digits. Okay, now you may ask, is 5 too many? 5 is too many. We don't really need 5. But I'd like you to be accurate in your answer to 3. So especially if I'll probably grade you to 2. So if you're accurate to 3, then you have no problem. Okay, and if you make a rounding error on your 5th digit, that's not going to affect you. So that's why I tell you to keep 5. Okay, so so this is AX and AY. So I can say then that A equals, I put degrees on there. That's dumb. You know, these things happen. Okay, pounds. Come on, you can do it. Pounds and pounds. Okay, so A equals 37.682 pounds in the I direction plus 213.70 pounds in the J direction. Now, some people will put a little arrow, some people put a little hat. I don't really care what you put there, okay? So that's A. Okay, let's do B. Okay, here's B. Here's my angle is 26 degrees, and let's suppose I want that side. Okay, well, that side is, B in the Y direction. This side is B in the X direction. So SOHCAHTOA, so sine of 26 degrees, okay, is the opposite, BY, over the hypotenuse, 408 pounds. Okay, the cosine of that angle, so C, that's adjacent over hypotenuse, so that's BX over the hypotenuse, 408 degrees, not degrees, pounds. Okay, so again, I can rewrite these, and I can say that BY equals 408 pounds times the sine of 26 degrees. Okay, and BX equals 408 pounds times the cosine of 26 degrees. Okay, and I can plug those into my calculator. All right, so we get these fancy numbers, and I can go ahead and do B, just like I did A, equals, let's see here, BX, 366.71 pounds in the X direction, plus 178.86 pounds in the Y direction. Okay. Now let's see if that makes any sense to us. Okay, notice B is much bigger in the X direction than the Y direction. Based on this small angle, I'd say BX is much bigger than the Y direction. And A is much, much bigger in the Y direction than it is in the X direction. And that also makes sense. Okay, so to add these two, I can say, okay, well, let's say C equals A plus B. Okay, what I'm going to do is I'm going to add the I components, like that. So I'm going to add this and this, okay? And then the J components, okay? And for the J components, I'm going to add this and this, okay? Okay, and so if I wanted to report this, which it did ask, you know, for your answer, to just add them. And so this would be one way to do it, okay? Plus 393 pounds. Okay, so that would be one way to report it in the J. I hate this way of reporting it, right? Because you'll almost never have a professor that's going to accept that anyway. So we're going to try to turn this into, so what we want to do is want to know the magnitude of this vector. And so the way we do that is we recognize the Pythagorean theorem here. So basically we've got a triangle that looks like this. So it's, well, it's not a very good representation of it, not to mention I didn't use a straight edge. So let's use a straight edge here. It's about the same on each side, right? So one thing that you will notice is if you've got the X side is 400 and the Y side is 400, more or less. So we'll do about 4 of these in a little bit for the X side. And then the Y side is a little bit under 4 of these. So we'll go 1, 2, 3, and a little bit under 4 like that. You can see that this angle is going to be pretty close to 45 degrees because the X side and the Y side are the same. Okay, so this is the the vector that we're looking at here. And this angle right here is going to be a midge under 45 degrees, right? And we'll solve for that in a second. Okay, but we know that this is 404 pounds because that's the x side, and this one is 393 pounds. Okay, and so we want to know what is the magnitude of c here, right? And so we're going to use Pythagorean theorem, which is that the c squared equals, or c equals the square root of a squared, 404 pounds squared, plus b squared, 393 pounds squared. And c, the magnitude of c is, and here I'm breaking my own rules. Hold on a second. We want to work with the full number here. So let's work with the full number. 404.39 pounds squared plus 392.56 pounds squared. Okay, so we'll plug that into the calculator. Okay, 563.59 pounds. Okay, that looks pretty good. Okay, so that's the magnitude. And then what we need is this angle. And so we have to think SOHCAHTOA. Okay, and the sides that I have the opposite side, because this is the hypotenuse. Okay, because the hypotenuse is across from the right angle. And so I've got the hypotenuse, and well, I really have all the sides, but typically what we do in this case is you do the opposite side and you do the adjacent. Okay, so the opposite and the adjacent, that's TOA. Okay, tangent of theta, so tangent of theta equals the opposite side, which is 393. Well, let's use the full thing. That way we won't have any errors. We won't have any rounding errors. 392, excuse me. We don't like rounding errors. 392.56 pounds divided by the adjacent side, which is 404.39 pounds. Okay, so what we'll do is we'll solve that, and we'll get theta equals, and we get tangent equals 44.1495, so 150 degrees. Okay, so in other words, C equals 564, because we're going to round that, 564 pounds at, not at, well, I guess we could do at, well, at an angle of 44.2 degrees, okay? And if we've done this right, it will equal what we did earlier. And let's see if it does. I don't remember. Ooh, we're off. That's interesting. Well, give me a second. Let me search for my error. Okay, so let's see. If we look around here, I found the error. Let's see. So these things don't quite match exactly. So what we need to do, actually, we need to find it. And it's interesting because I'd already kind of underlined it right up here. Is I basically had an algebraic error getting this number right here. And so that number should have been, let's see, so if I redo the algebra there, I get 563.59 pounds. And so if I plug that number in here, 563.59 pounds, then this angle ends up being 35.850, which makes this 35.9. Okay. So if I put that in over here, 35.850, then this angle becomes 44.150 degrees. Okay, I mean, the procedure was exactly correct. And this number right here ends up being 564 pounds at an angle of 44.2 degrees. Okay, so pretty sloppy. Quite an error, and it's really unusual for an algebraic error to end up so close. I mean, we're only off by, like 1%. So that's pretty crazy. Obviously, it creates some errors all the way through. But if you did it, I would post the actual key online, just a paper key and I didn't make this error there. But it's one of those good things. I guess it was an unintended positive of making you check this. Okay, so like on a test, if you had time, you could check your answer by doing it both ways and just making sure that you did it right. Okay, so that's it. So it's half an hour, including an error that we got to correct. So hope you're having a good one. Hopefully you didn't email me about that error before making it to the end. Anyway, hope y'all are having a good one. All right, stay cool on this warm day. All right, bye. Do that.